So we've looked at finding equations for tangents to a circle. And I want to review over that a little bit and then expand that to finding equations for tangent planes to a circle. So let's suppose that we have a circle like this one, x squared plus y squared equals 13, where the radius is the square root of 13. And I want to look at what happens right here at this point 2, 3. Now, 2, 3 is on this circle because notice 2 squared is 4 plus 3 squared, which is 9. So 4 plus 9 is 13. So 213 is on this circle. Now remember, the way we get the equation for this line right here, and I only show part of it, but the way we get that equation is we look at the delta x, and the delta x is 2, okay? And then the delta y is 3. So we have a slope of 3 halves, change in y over the change in x. So we could talk about that line this way. We could say y minus 3 equals 3 halves x minus 2. And that's the point slope form of the line. But remember, we also said this, that you could use a set of parametric equations. You could say, well, let's just describe the x coordinates. Well, it's delta x times t plus the x coordinate. So in this case, it's 2t plus 2. And then the y is the delta y times t plus 3. I get the 3 from right there. Now, we could have also just said, we could have used 0, 0 instead of 2, 3 to get this line and said, well, it's 2t comma 3t. But I wanted to put in this point because we're trying to get the tangent here in a minute. Now, what I've got here is a little line that comes out from the center of the circle. This right here is the radius. And what I want to do is find a tangent. Now, we know that the tangent will be 90 degrees with a line, a little segment that comes out from the radius. So a line that passes through the center of the circle here is going to be perpendicular to a tangent. Okay? In other words, 90 degrees right there. That's what's going to happen. Now, the way we get a perpendicular to a line is take the negative reciprocal. Okay? So our negative reciprocal for this is going to be negative 2 over 3. Or 2 over negative 3, however you want to look at it. But look, I want to point out something to you. I'm going to set up the delta x, delta y as a little array here. Delta x, delta y, like a matrix. So that would mean 2 up top and 3 on the bottom. This is my matrix, my little array here. Now, when we flip things, what we're going to get is negative 3 up top and 2 on the bottom. Now, this will give us what we need to do. So if I take this, 2 over negative 3, I get the slope for the perpendicular. Now, how would that look with parametric? Well, it would be negative 3 for the top part, negative 3t plus 2, and 2t plus 3. See? Because this is now in the y coordinate. This is now in the x coordinate. This is now in the y coordinate. So dig how that looks. So this is the perpendicular line. Okay? Here is the line. Here is the perpendicular. This is the tangent. This is this line right here. Now, I want to look at a property of when we set up a little array like this one and like this one, we can use this thing called the dot product. And here's what happens. Notice if I take the top numbers and multiply them together, 2 times negative 3 right here. And then the bottom numbers, and I put plus 3 times 2. See right here. So I've got the top numbers multiplied, and I'm adding that to the product of the bottom numbers. Notice when we have perpendicular lines, we get a 0 from that process. That dot product is 0. That little process is going to give us a 0. So it looks one way when we've got a slope here, we say negative reciprocal. Well, if we're looking at it with these arrays, we could say the dot product is 0. Now, let's take a look at, let's expand that a little bit. Let's suppose I've got a sphere, okay? Here's a sphere, and I've got this point 2, 3, 4. 2 squared plus 3 squared, that's 13, plus 16. So I've got, that would be 29, okay? So I've got 2, 3, 4, and here's the sphere with the point right here, okay? And I've got my equation for the line that comes from the center of the sphere up through here. So notice delta x is 2, delta y is 3, delta z is 4. And of course I get that, I get the delta x from taking the 1 point, 2, minus the other, because I've got 0, 0, 0 as the origin. Delta y is 3 minus 0, and delta z is 4 minus 0. Okay, so in other words, I've got my array with the delta x, y, and z. So the line that I'm looking at right here is 2t, 2, and then plus this t, or this value. And then 3t plus 3, 4t plus 4. And this is that equation right there. Now, what I want is a line perpendicular to that. That's what I want. I want a line perpendicular to it. Well, one of the things I could do is I could say 2, 3, 4. There's my original. And then just say, okay, well, let's let delta x, delta y, delta z be 1, 1, and a. And I'll choose a that will make this thing 0. And then I have the numbers that I need. Okay, I'll show you what I'm talking about. Let's do the dot product. 2 times 1 is 2. 3 times 1 is 3. Okay, 2 plus 3 plus 4 times a. And then I solve this and I get negative 5/4. So now what we have is we have our new inputs. We have the top number, which is going to be with the x, see? 1t plus 2. 1t plus 2. 1y plus 3. See? And then negative 5/4 t plus 4. And that will give us this right here. That right there. And that's a tangent to that sphere. Now, at that point, 2, 3, 4. Now, let's go back and look at this a minute. Notice that up here for the circle, we had this 2, 3. Delta x, delta y. In other words, the number that goes with in the x-coordinate, the number that goes in the y-coordinate. Now down here, we flip those, and now I've got negative 3 here and 2 here. I just flip those and change the sign of one of them. Now this one, the first number goes with the x, the second number goes with the y. Okay, that's just me flipping them. Now down here, I didn't do exactly that. I didn't just flip these. I just put a 1, 1, and then said, let's figure out what a needs to be so that the dot product is 0. But notice, I could have just flipped them the way I did for a line. Okay, let's dig that a minute. Let's suppose I had the 2, 3, 4. That's the original delta x, delta y, and delta z. And let me just flip these two. Negative 3, 2. Just like I did for the line. And then for the z, I'll just put a 0 there. Well, heck, that will work. Notice, 2 times negative 3 is negative 6, plus 3 times 2 is 6, plus 0. Yeah, that's 0. So look what I can do. I can say negative 3t plus 2, 2t plus 3. Remember the point was 2, 3, 4. And then 0t plus 4. And this is my equation. Now this one right here is this orange one. Notice both of those are tangent at that point. The blue one, which is what we did earlier, this one up here, and then the orange one is right here. These are tangents. They're both tangents to the sphere at that point. Now notice all I did, dig what I did here now. I had 2, 3, I just flipped them and changed the sign of one of them. It doesn't matter which one. I said 2, 3, I changed that to -3, 2, and then I put a 0 in for the z part. Just like, I treated this just like a line, okay? Now, or just like a circle, finding a tangent to a circle. Now, I want to expand on that and talk about, well, what happens if I want a tangent plane? Okay? Now, in other words, I want a plane that contains all the tangents. Look, I've got 2 tangents here. I want a plane that these tangents are on that plane. And I'm going to call that the tangent plane. Now notice that this line right here, the original line, which I had delta x, delta y, and delta z, is perpendicular to all these tangents. So it will be perpendicular to the plane. Okay? Now, I'm going to take this point, 2, 3, 4, and I'm just going to pick some other point on the plane. This point, x, y, and z. Let's just suppose this is on the plane. And let me get the delta x for that one. Delta x is x minus 2. See? X minus 2. Okay? Delta y is y minus 3. Delta z is z minus 4. This right here is what I want to use to do the dot product with this one. And when I do that dot product, what I'm going to get is 0 because they're perpendicular. Okay? So let's do the dot product. Here I go. The dot product of this one with this one. Okay? So look. Delta x times delta xp. There's delta x times delta xp. Delta y times delta yp. Okay? Delta z times delta zp. And that has to equal 0. Now let's put in 2, 3, 4. 2, 3, 4. And then these are just what they are. And if you graph that with the sphere, what you're going to get is this green plane. And notice how that the blue and the orange are both on that, plane. That's what we call the tangent plane. So let's look at this. Let's look at this again. Let's suppose I've got x squared plus y squared plus z squared. And let me just pick a point here. I'm going to say 1, 3, and 5. I'm going to pick that point. So let's see what that's going to be. That's going to be 1 plus 9 plus 25. I guess that's 34. Okay, so let's double check here. I've got 1 squared plus 3 squared. That's 10 plus 5 squared. Okay, so that's 25 plus 10. Oh, that'd be 35. Okay, 35. Okay, miscalculate there at first. Okay, so let's suppose we've got this plane. And we get our original delta x, delta y, and delta z. Our original delta x, delta y, and delta z is going to be 1, 3, and 5. Okay? Okay? Now, my original equation then is going to be t plus 1, 3t plus 3, and 5t plus 5. Now, what I want is I want an equation that's tangent to that. So here is the tangent I want tangent to that sphere. So here's what I'm going to use as my tangent. I'm going to have delta x. Let me do it this way. I'm going to say, I'm going to use this. I'm going to say, okay, here's my tangent. I'm going to say -3, 1, 0, or 5. No, 0. Like that, okay? Now, so this is my tangent, -3t plus 1, t plus 3, and 5. That right there is my tangent. See? What I did was I flipped these and changed one of their signs and then put a 0 here. This will be tangent to this sphere at this point, 1, 3, 5. See? 1, 3, 5. See? So I've got my new delta x, delta y, and delta z. Okay? Okay, so I'm going to say, okay, now, let's do this. Now what I want is I want my tangent plane. Okay, so here it goes. My tangent plane, I'm going to go back to using this right here. So here's what I've got. I've got 1 times x minus 1 plus 3 times x minus 3 plus 5 times x minus 5 equals 0. Now notice how that's like this one right here. Okay, this one right here. Very similar to that. This will give you the tangent plane. So notice, here is my original line. I just get the delta x, delta y, delta z. To get the tangent one, I flip the first two here and put a 0 down here. See? The x, the first thing is the x. The second, the y. And the third, the z. So -3t plus 1, t plus 2, t plus 3, and 0t plus 5. Now, to get the plane, I've got my perpendicular, x, y, delta x's, delta y, delta z, and I get another delta x, delta y, delta z on the plane. This right here is the delta x on the plane, the delta y on the plane, and the delta z on the plane. That's what these are. Okay. And this is, so we broadened, instead of just finding the tangent to a circle, we're finding the tangent to a plane, to a sphere, and also the tangent plane.